So chapter 6, objectives for us, looking at labels. We already started looking at labels, so reading reconstitution labels like I just did. I read a label and that determined how much diluent I added. So figuring out that these terms, dilutants, diluent amounts, how the dose goes, normal calculation with our metric system, that's never going away. Understand how to reconstitute and measure liquid medications. Again, you aren't physically going to be doing any reconstitution, but I really want you to understand the concept, and that's why I spent that time doing that demonstration. That it helps for a lot. I know it helps for some people to physically see it, what's happening, physically, tangibly see it. It's not just a concept. You can see what the process is. And basically just understand how to reconstitute that. It's mainly going to be for liquids and stuff. The first few slides here are going to be a review of what we've done already, but just as a reminder. So all liquid medications, it's just telling you again with, and this is talked about in the first couple pages of the chapter too, if you're following along there. It's from there, but medications that are liquid, if they're oral, they're going to go in a medicine cup. We've looked at the medicine cup, measuring them. They're talking about measuring to the meniscus level. That means if you look at all liquids in a container sometimes, they're going to have a little bit of it's going to look like they're a little bit rounded. You're looking at the middle bottom, and that's where the lines are, right? So when you're measuring a medicine cup, the best thing to do is set it on a table, right, or a flat surface, and, pour your medicine, and then do your eyeballing. Get eye level and look, am I at 10 milliliters? Yes, okay. Am I slightly above it? Okay, dump a little bit out and keep putting it. So I always kind of just put stuff at like a table level, and then I just get down and look at it and go, okay, yeah, dump a little bit out, put it back down, that kind of stuff, okay? If you want to be exact the first time, there's a way I talked about doing that. Do you guys remember? Especially if you didn't have it, what if you had to give 7.5 milliliters? You put it in a syringe. So we make oral syringes. I don't have any here, but the oral syringes, the only difference is they're the same size as all the other syringes. The only difference is they just come with a little slip tip, basically, on the end of them. A tip that's designed to go into liquid and draw it up. Not the lure lock where it has a little locking mechanism for IV syringes. Designed to go into liquid. You can draw up exactly what you need, put it in the medicine cup, means that there's no eyeballing or anything like that. Is that a quicker solution? Not necessarily, but if you got to be the most accurate you possibly can, that's the way you need to do it. So that covers a lot of that stuff, I think, there. So some definitions, some words to know, mainly because I'm not going to test you on definitions, obviously. That's kind of silly. This is a math class. But when you hear words like this, you need to know what they mean, because if you don't understand what these mean, when you read a problem, right, you don't know what number to grab, what number to ignore. You have to understand it. You can't just look for the numbers and that's it. If you do that, that's when people get down a rabbit trail making mistakes. So, again, this PowerPoint's on D2L, and the definitions are in the book. On the first 191 to page 192, these are all here. But concentration, again, I've told you, amount of solute that is dissolved in a certain amount of fluid. So what is that saying? Again, this is what I always do for A&P. I always do this example of I've got 2 beakers or 2 glasses, right? Okay. Each of these guys, let's say, have 3 something in there. I don't know. We could do lemons because I think that's always I should have done them round then. But they each have 3. These solid particles are known as the solutes, okay? Solid particles. So, for those that haven't been in A&P, what we're talking about is concentration is a comparison of the number of solutes to the number of liquid. So, if I have this beaker filled up to the brim with liquid and this one only has a little bit, which one is more concentrated? The one that is not filled up as much. This is more concentrated. That's where that word concentration comes from. Or concentrate, like you think of with lemons or whatever. Because there is the same amount of solutes, the same amount of particles, right? But there's less liquid in here. So compared from liquid to particles, this is more concentrated. This would be what they would call more, anybody know what you would call this? Yep, diluted. It's more diluted down. It's more watery. It's more liquid compared to the particles. So reconstitution is just saying, I'm just starting off with just particles, and I add the liquid, mix it all up, and I'm going to make the concentration. I'm going to make 3 solutes compared to this solution, because the liquid is a solution, and the weight, mass, the heavy physical particles in that are known as solutes. So the solution is the liquid, solutes are the particle in there. And so concentration, all that word is saying, I've got this much solutes, this much milligrams of medication or grams of medication, whatever, mixed in this solution. If this solution is whatever total liquid, concentration says, I got 3, whatever solutes per whatever, 5 milliliters of liquid. That's a concentration. That's what we've been working with already for medications. We've been working with medications that come in liquid form that are 10 milligrams per milliliter, whatever, what have you, right? So that's all, again, concentration. I am stressing the vocab because if you don't understand the vocab, you can't comprehend the word problem. If you can't find the right thing in a word problem, you're never going to get to the right answer. Again, the basic math, if you do desired over have or ratio proportion, the basic math does not change. You just got to get the right number in there. That's the point. So dilution is adding a dilutant. Or I say dilutant. I think, is Miss Manners out there? Miss Manners says diluent. I've also heard it said on the video that way, so she's not wrong as far as I'm concerned. Again, diluent. Yep. She was in Cheatham County for a long time. That's where she taught. Hey, I didn't go to Cheatham. I went to Sycamore. I was a Pleasant View guy. All right, but yeah, whatever. I still lived in Cheatham County.
I live in Cheatham County.
Ain't nothing wrong with Cheatham County. It's better than Metro Nashville. I mean, no. There was like three when I went to school. There's like 3 when I went to high school. I could name them, actually, probably. I could probably name all the different race people I went to school with probably right now if I sat down and thought about it. I mean, I like it out there. There's less problems than there is. Yeah, less problems than it is. I would never live in Nashville. You couldn't pay me. Yeah, you'd have to pay me like a large sum. All right, so dilution is the term that says I'm adding that liquid, what we did. When I add the liquid, I'm adding a dilutant. A dilutant is just a word for the liquid that's going to be added to the powder and make it into a solution, make it into this part solid mixed with this part liquid. So a dilutant, for example, if it said something like this is like the word problem. Add 106 milliliters water to a dry mixture in the bottle to achieve a final concentration of 125 milligrams per 5 milliliter. So again, I put this really wordy for a reason, right? Final concentration, there it is. Parts of medicine per liquid. There's concentration. What is this? Add blah, blah, blah of water. What is that? This is the dilutant. Okay? So right now in that example, you only have a part of the puzzle. The only thing you have right now is the concentration. You need an order, and then you're off to the races. This number right here is not factor into your math about you finding the dose. It's the same thing. To find a dose, I need this. I'm always looking for a concentration. What does this medicine come in and how much is in there? And then I need an order. If I have those 2 things, I'm off to the races. I don't need anything else. So this dilutant amount, 9 times out of 10, is going to be an irrelevant number for your math. It is not going to affect you finding a dose. If you don't have a concentration, we're talking about a different ball game, and that's something I'll have to teach you at another time, because maybe we'll get to that today. But there's a reason I have dedicated 3 weeks of our schedule to this. We have 3 whole classes dedicated to this. So it's going to be a slog, but I have to nail this for you guys. I have to nail this home. So diluent is just what I add. Again, 99% of the time, that diluent number is just a rabbit trail. It does not help you or anything find what the dose is going to be, how much you physically walk in the room and give a patient. It's not going to matter. Now, if it were in the real world, it does matter to tell me how much I'm supposed to put in here and mix. We're not talking about real world. We're talking about math world. We're just talking about what's the numbers, plug them in. Another definition is reconstitution, what I've been explaining this whole time. Adding a diluent, your fluid, to a powder to achieve a specific concentration. That is the definition of reconstitution. So, right, example, dilute with 3.5 milliliters of sterile water. That's the diluent. Dilute with is saying, take this water, add it to a powder, and then you will get a concentration. And then you work from that, okay? So don't overthink this. It's not complicated at all. It does not change your math at all. It's just more words. Words, like I always say, can't hurt you, okay? They can confuse you if you let them, but nothing is changing, okay? Nothing is changing. This is not changing anything. So this is my explanation of concentration. Again, the amount of a particular solute, a particle, a solid thing, in a given solution. So again, they're just showing you the same thing I just showed you. This picture is saying, I got two things of water that are the same. I have less particles here, more particles here. This is now more concentrated than this solution because it has more particles compared to water than this guy on the left, okay? So this is the more concentrated solution. That's what concentration is saying. Does that make sense there a little bit? And then again, same picture here. Don't get hung up on it's just a picture to try to show you this concept. Again, they're showing you the same thing I showed you the first time. They're showing you a liquid with a little bit of liquid in it, higher concentration. But if I add more liquid, look at the color change too. Do you notice this? You see that color gets a little bit lighter, right? Because there's more water compared to the solid particles in this liquid now. This is just like urine, okay? I know it sounds gross, but if you've ever noticed pee in the toilet is very dark, okay? Darker amber colored versus like lighter, more watery colored with a hint of yellow, that is, the darker urine is more concentrated. It has more uric acid, more minerals in it, more waste products. That way it looks darker. It is more concentrated. It's more like that versus like healthy that pee, okay? That's what concentration is saying. And it uses the word adding a solvent. A solvent is another word for adding liquid to a solution, but we don't have to know that one necessarily. So we already introduced labels for a reason, but just to give you kind of, again, the rub of the whole thing, reading the label is going to be part of this chapter, and you're going to start seeing labels on the test, and I'm going to throw more labels at you on the last test. And then everything you've done in this class you could see on the final. But the final is still only 25 questions. So, excuse me, you can basically expect the final to be, of all the 4 units of information we've done, basically like a 5 to 6 questions from kind of each thing we've done to fill up 25 questions. That math's not right. Something like that. 6 or 7. So labels, they're always going to tell you what the drug is called. They're going to tell you how it's made. This drug was made for an oral suspension. So that means a liquid, a suspension, or solution. So I'm on an oral liquid. And then this one gives you the concentration in bold for you to see. 200 milligrams per 5 milliliter. There's your concentration. That's what you're looking for. And they tell us too here that, again, it gives us to it in a couple places. It gives us a concentration again there. It gives us instructions. But here, though, it gives us something interesting, and sometimes they don't always do this. You can't see it very well. I didn't think this ahead, but come on. Why you hate me? So, okay. The instructions over here are interesting because the instructions on the side here say add 45 milliliters, what does it say exactly, of water, okay? That's really, so what is it? What is this saying? Add something. What is that saying there? What do you call it? That's the dilutant it's saying. It's saying that this is starting off as a powder. I want to mix this up so it's something that can be poured as an oral drink. And again, liquid medications for a lot of you guys will be common, okay? There's a lot of elderly patients that are going to have trouble swallowing. That's very common. So this is not something you're never going to see. So that tells me again how much I'm supposed to mix in here, right? And it also here tells me, it doesn't tell me here, but it tells me down there that the total amount in the bottle, by the way, is 3 grams worth. It says in the instructions. So that's always somewhere. Does that matter? Not necessarily. It could matter in the future, just like the total amount of liquid in here matters. Look right here. It says 75 milliliters up here in bold, but then it says in parentheses, when mixed. You notice that? When mixed. So this is saying after you reconstitute with exactly what the manufacturer tells you to. Again, a dilutant amount is not something you're making up off the top of your head as a nurse or anything. The manufacturer of the medication has designed this to do that. Again, why didn't they just ship it in a liquid? Probably because it has a short shelf life or half-life, like meaning that it can't sit on the shelf for weeks on end in its liquid form. It will go bad. But it can sit somewhere in its powder form until it's ready to be used. That's why you would have reconstitution in products like these. A lot of antibiotics are like that. They can't be mixed when they're manufactured, sitting in a box somewhere. But once they are where they need to be and they're ready to go, take them out, mix them, and then you're ready to go into the room. That's why reconstitution exists. So this is saying that there is 75 milliliters total in here after I've mixed it, after I've reconstituted. That's all reconstitution is mixing it up. I said, like, make a martini or whatever. Although I think James Bond would be disappointed. He wants he wants shaken, not stirred, right? No, yeah. So again, just hammering home the same concept here. Reconstitution medication levels. You're looking for labels, and we're looking for this to read it, to understand it. So read a label prior to making any decisions about anything. So this one, again, has a concentration in here twice with the name on it. 125 per 5 milliliters. It tells us what it's supposed to be for oral suspension. And then it tells us again that clues you're looking for to tell you things is the same we've always had. But it says things like, when reconstituted, each 5 milliliters contains this much. So that's telling you that I reconstitute this, I'm going to gain this much medicine, this much concentration, this much medicine per this much liquid. Same thing we just looked at. Total volume in here when reconstituted. When I reconstitute is 100 milliliters, okay? Now this one's a little bit hard. This one doesn't give you the exact number for reconstitution, which doesn't matter. That doesn't happen that often. Most of the time, they're going to tell you exactly how much water, how much dilutant to add. This one says 2/3 of a total water. It's talking about 2/3 of the container. Basically, you'd pour in water that filled up the container and you shake it up. That's kind of old school. That doesn't happen that often, so don't stress it. But again, it's telling you kind of information. It's telling you what the total is. So again, it's going through this stuff and asking you, but then it says right here, what's the total I add? Oh, it actually is saying 2/3 water, blah, blah, blah. What does that mean? Oh, no, it actually says total is 90 milliliters. That's your dilutant. So here it is. That means there's only about, that's what I was talking about, displacement factor. If you think about it, it makes perfect sense. It's saying, here's a container. It's got some powder in it. You need to mix it. You take a dilutant, in this case 90 milliliters. When you get done mixing it all up, it's going to give you this concentration of 125 per 5 milliliters, meaning, again, 125 milligrams per this much liquid. The total volume, the total amount of liquid after you're done is 100 milliliters after you reconstitute, total volume. So I added 90. I had a total of 100 after I'm done. That's what I was talking about. That means that that powder took up about 10 milliliters of space. Again, You're like, how does a powder measured in liquid? Again, liters and milliliters is a liquid measurement, but it actually measures volume. And all volume actual definition is how much space a container takes up. So they talk about this in the book, but this is something that the book does some problems where you figure it out. I'm never going to make you figure this out. But if I added 90 to mix it up, and I've got 100 milliliters after I've done the mixing, the reconstituting, they call this difference a displacement factor. This is the volume the powder takes up in the container. So what's the displacement factor? How much volume did the powder take up then? See the difference there, right? The difference between these two numbers, 10 milliliters. So this is saying, again, that the powder does take up space. But again, you see, they already do this for you. You don't have to necessarily figure this out. They tell you what the concentration is after you mix it. They tell you what the total liquid is. So if I asked you a question about how long will this bottle last, you've got the total amount of milliliters in here. So you just see what the dose is and figure out how many doses you can get out of it, something like that. Those solutions, you're always doing the same thing, though. You've got to know what the dose is first, otherwise you can't move forward, right?
And does that call for some hot water or?
It just says add water, so it's probably just talking about tap water because it's a liquid. Typically, I'd get water, filtered water, and add it.
Yeah.
I wouldn't do just regular tap water. I'd do filter water.
Yeah.
But it just says add water, and when it's a liquid like this or a oral liquid like this, my assumption is just whatever's healthy drinking water would be sufficient. Doesn't have to be sterile or anything because anything going in the stomach is not going to be sterile anyway. Nothing you eat is really sterile. It has bacteria, it has pathogens on it. For the most part, all of them do. So, let's take a break, probably. Let's take a break because I'm sure brains are a little bit melted. Is this making sense though? I don't feel like. Okay, like I said, just don't. The thing with this is just never overthink it. Just always remember that the problem is the same. The problem is I need to have something I know. I need an order, and then I can figure this out. As long as I have a ratio or a concentration is a ratio, this much medicine, this much liquid, as long as I have that information and an order, I don't need anything else, okay? I can figure out a dose from there. All right. Reconstituting for parenteral. I always hate parental. I say parental, but I think it's parenteral. But parental is just the name for IV or IM injections. Anything injectable is parental. That's what it's going by. So again, what you need to know is what is the medicine I'm diluting, and it talks about displacement factors. So again, I am not going to focus on this class. It's nice to know in the future, though. Again, that displacement factor is what I just talked about. Displacement factor is usually told to you by the manufacturer is that difference between what a diluent I added and what the total volume is going to be at the end. The displacement factor is the difference between those two, and that's just saying, hey, this is how much medicine is actually in here, how much space that medicine takes up, that powder. So it's a nice to know. It's not a need to know. I'm not testing you. I'm not doing tests. I'm not doing any test questions where you have to worry about displacement factor. All the info you need to solve a problem is going to be there for you. You don't have to make it up or find it, okay?
Can you do like a little something for
It's about pulling out the right information. Okay, let's look at what we do know, right? The order is for procaine, penicillin, G, whatever, doesn't matter. Order for something, 300,000 units, IM, BID. So right now we know the order is, right, 300,000 units of something. Correct, we got that. It's IM, BID, which means it goes in the muscle twice a day. Again, we don't know if this is relevant, so question mark. Move on. There's a 1 gram vial of procaine, penicillin G, obtained from the dispensing system. All that is saying, I grabbed it out of the system. The directions on the vial state, for IM use, dissolve 4.6 milliliters of bacteriostatic water for injection to make 200,000 units per milliliter. All that's saying in words is if I take this diluent, right, 4.6 milliliters bacteriostatic water, I yield, that's why I yield a concentration, you see this, of 200,000 units. I'm trying to go too fast. 200,000 units per 1 milliliter. That's what it's saying. You see this? That's all that problem is saying in words. Then it asks you how many milliliters / dose should the nurse prepare. This is telling you what are you going to draw up and walk in the room and poke the patient with. That's what it's telling you, okay? Oh, yeah. So it's 300,000 is what I want. That's the order. That's our desire. 200,000 units per milliliter is what I have, what the concentration is. So with these problems, you're always looking for something. You're looking for a concentration. You're always looking for how much medicine is in how much liquid. This is your eyeballs are always looking for that. So all the information you need is this is my known, this is what I desire or ordered. I don't need any of the other information. The 4.6 milliliters of bacteriostatic water is just facts that don't help me. All they do is tell me if I was a nurse how much I'm supposed to put in there and physically mix. They don't tell me any information about solving for the dose. So it doesn't change what we do. We do the same thing we always do. I know I have 200,000 units. Tired writing zeros already. Right? To 1 milliliter equals 300,000 units to X milliliters. And I just work it like I always would. Means and extremes, inside, outside. So 1 times 300,000 is 300,000. 200,000 X. Again, you can get rid of some of these zeros if you wanted to. If I divide by 200,000, that gets rid of it. 300,000 divided by 200,000. Anybody? Should be 1.5, but yeah. 1.5? Is this making sense? This is no different than anything you've done before, is it?
That's right.
It's the same, right? 1.5 milliliters. So this is saying if I want to give this patient exactly the order of 300,000 units, I go in, I mix this thing up. Again, that's the nursing side. You're not going to be mixing thing up right now. As a nurse, I mix it up. It gives me 200,000 units per milliliter. That means that I have to draw exactly 1.5 milliliters up, and I walk in and give it. That gives that patient exactly 300,000 units of the medicine that's ordered, okay? But again, I'm looking for the same things. Give me an order. Give me a known here. The known is 200,000 units per milliliter, and then I'm doing the same thing I've done the whole time. I'm not changing anything. So don't let all the words or the rabbit trails of this stuff throw you off. Reconstitution is everybody's linchpin. It screws you up. It's going to make or break this class. And for most people, it's seriously just don't overthink it. Don't make it more complicated than it needs to be. It's not. It's just words, okay?
So really, out of the 100 words that's up there, we don't read it.
Yep. I mean, that's every word problem ever written, though. I don't know what you... Just more information. I mean, these are directions. This is what you would read.
And so we don't do it the way you showed us with the, how you did it at first.
There's no, yeah, you do it the same way we've always done it. You're talking about, you don't have anything to pick here, though. Is you talking about picking a different, you talking about a solution? They gave multiple options? They only gave us one diluting options. It's the same thing. That's the same thing, though. You just don't have multiple diluting options in this problem. You're only reading the label and it tells you one option, so you're not going to make something up.
And we're not going to get to that yet. It's just going to look like
No, you're going to get the other ones, but I'm going to tell you. I may give you a label that has the options, and I'm going to say you as the nurse picked this much dilutant. And then you just go down and look at that dilutant and go, it'd be the same wording as that. It says the nurse, as a nurse, and a label that has this. As a nurse, you picked 20 milliliters of dilutant. You go, okay, there's my concentration. And you just don't, that's all you got to do. That's the only extra step, but it's just looking. It's not, you're not changing numbers. You're not making decisions about anything.
And that's always your no? Like your...
Your no is always going to be a concentration, for the most part. I mean, unless you're trying to find... Right? What if I was trying to find how much the dose is going to last? I need to know the total amount in the bottle. And then you could do the doses stuff. Remember the doses stuff we did, like full doses a little bit? We did a little bit of that. It's the same concept. I got to know how much the total is in the bottle. Don't get overwhelmed. It is not overwhelming. You're only gonna make it hard on yourself. You gotta just. I'm telling you, you're gonna make it hard on yourself. If you get stuck in this rabbit trail. There is 2 practice sheets. Whoever's still in here, there is 2 practice sheets on D12 for this. 2 of them. Okay. Yeah. Do them. Yeah. Do them and then ask me something. I would say they can be okay practice. The only reason they're more confusing is asking questions you don't have to stress about. It's asking you to pick and you're not going to pick. So if you do the practice sheets, those are in line with all you'll see from me.